Looking at section 2, we're looking at properties of matrices. Matrices is the plural form of the word matrix, and a matrix just means it's a group of numbers. So they put square brackets around them, and they line them up in rows and columns, and they have certain properties to them. When we add and subtract them, you just add or subtract the numbers in the same position. So the upper left corner gets added with the upper left corner, the upper right corner gets added with the upper right corner, so on and so forth. So, looking at,
Put the answer in brackets.
yes, you put the answer in brackets as well. So we're going to get an answer that's the exact same size of 3 by 3, 3 numbers by 3 numbers. What would that first number be if we're subtracting these? No. 6. 4 minus negative 2 would turn into 6. What about the number to the right of that? Questions? It'll tell you right here.
Oh.
There's a minus right there. Questions? No, there's really no work to show on adding and subtracting. On multiplying and dividing, yes. And we'll get to that. But no work needs to be shown on these problems. Question?
Would that be a
Yes.
That's an armadillo. Do you know where
We ready?
South Asia. Yeah.
All right, so we're going to actually be using these to do what we did last week, which was to translate figures. If you don't have the notes, you don't need this picture, but you do need this. Okay, so you need to have a matrix here with the brackets. You need to have x coordinate, y coordinate, and ABC across the top. Nope, you don't need to draw the picture if you don't have the notes. Because the important part is the actual matrix. So underneath A, you're going to put the coordinates, which would be 4, 2. B is 2, negative 3. And C is negative 5, 5. So when you do these problems, you don't necessarily need to write this, but you do need the letters with the numbers underneath. You do need to label them across the top. So anytime you put something in matrix form, you do need to label it with what coordinates are labeled there. All right, so this is what your problem would look like. So we're going to move this along the vector 6, negative 1. We're not going to graph it. They just want to know where the coordinates are going to end up. So what you're going to do is you're going to take your original, which is A, B, C. We're going to add to it the vector, and it's going to end up as, how do we label things after we move them or do something to them? What did we learn last week? Yep, a little apostrophe after it. A prime, B prime, C prime. So it'll end up at 3 new coordinates. So ABC we already know, it's right up here. So we've got 4, 2, 2, negative 3, negative 5, 5. How do you think I could write that vector in the next matrix? Yeah. All of your x values, which are on the top, are going to move 6. So you have to put 6 across the top on all of those. And all of your y values are going to be decreased by 1. So you put negative 1 across the bottom on all of those. So all we do is add, which is just what we did on the previous page. So what's A prime going to be? What are the two numbers underneath A prime? 10 and 1. So the new coordinate for A prime is 10, 1. What about for B prime? Okay, what about this one? 1, 4. Questions on that?
No.
Pretty easy? Anyone still need this page? Okay, moving on to the next one then. Scalar multiplication. Scalar multiplication just means that everything is going to be increased by the same amount. So we have this matrix, and then there's a -2 on the outside. What that means is all of your numbers get multiplied by -2. So this also doesn't have any work to go along with it. We're just going to write what the answer would be. We take everything times -2. To get the answer. The next portion is going to take quite a bit of brain power. So if you're feeling a little bit lazy right now, you may want to change that because you're going to need your brains right now. So scalar multiplication is just if you have a number out front and you take everything times that number. If you have a matrix times a matrix, there's a very specific way that we do that. And my X kind of got moved here, but there should be an X in between here because you're multiplying those two matrices. So this is our problem we're going to start with, and we're going to multiply these two matrices, and I'll show you how to do that. So wait till everyone's got this problem down. So whenever I see one of these problems, this is how I start the problem. I'm going to circle all the rows on the first one and the columns on the second one. Always. Rows on the first one, regardless of what shape or how many numbers there are, you always circle the rows on the first one, columns on the second one. The reason you do that is because you're always going to be taking rows times the columns. There's always going to be the same number of numbers. There's two numbers here, two numbers here. If you don't have those numbers matching, you can't multiply them. And you will have scenarios like that, and you just say there isn't an answer. You can't multiply them. So we have two numbers times two numbers. Here's how this works. You don't need to continue to rewrite this over and over again. If you have the notes printed out, great. But you only need to write down this problem once. I am just very slowly spelling out how I'm getting these answers. So you're going to take 2 times 2 and 0 times -3. The first number times the first number, second number times the second number, and then you add those two together. So that's what I wrote over here. 2 times 2 plus 0 times -3, which is 4. And then I've highlighted in green the same process. We take the top row times the second column. So we take 2 times 1, 0 times 0, and we add those two together. So what would that be? 2 times 1 and 0 times 0. That would be 2. 2 times 1 is 2, 0 times 0 is 0. If you add those together, you get 2. So our first two numbers across the top, there's a times here and a times here. We would have 4 in the upper left and 2 in the upper right. So I'm just going to continue to go through this, and we'll do another example after we're done with this, just to make sure we're understanding. So I continued this whole process. This 2 should be written over here. Okay, so we're done with the first row because we got the two answers in the first row. We have 4 and we have 2. So now we're working on the second row. We're going to multiply it by both columns. So we took this one times this one to get this answer, which was -9. The next one is the two gray ones here. So we're going to figure out what this is and then actually get the whole answer. So you always take the first number times the first number, second number times the second number, and add those two together. So if we're looking at the gray ones right here, what are we going to multiply? -3 times 1 and 1 times 0. So when you get those two answers and add them together, you get what? -3. So -3 will go there. So I'm going to you don't have to keep recopying this down. It's the exact same problem. In order to get the answers in the bottom row, we have to use the bottom row to get those. So we're looking at the bottom row, and then we're looking at both columns. So we've got 4 times 2 and 5 times -3. So the first number would be what? 4 times 2, 8 plus what? 8 plus -15 would be 8 plus -15 is -7. So why didn't I put this -7 over here on the right? We're looking at the first column, the bottom row. Well, coincidentally, we're putting our answer in the first column, bottom row. So whatever two you're overlapping, that's where your answer goes. So if we want the answer in the bottom row on the right-hand side, we have to use the bottom row and the right-hand side. So we're going to take what times what? 4 times 1 and 5 times 0, which would give us an answer of 4. We're going to try this again. Are there questions on the process itself? Yes?
So you take the two numbers and you multiply the two sides and then you add the two sides together.
Yep. Multiply the two sets of numbers and then add your two answers together. So let's try it with this one. I'll give you some time to write it down if you don't have the notes. What are we going to circle on the first one? Rows or columns? Okay, so we'll circle the rows here, which means columns have to be circled here. Okay, so if I want the answer in the top row, first column, that's what I have to use. The top row and the first column. What am I going to multiply by? -1 times -3 and 0 times 5. What is that? You get 3 when you add them together. Okay, if I want the answer in the top row on the right column, I have to use the top row, the right column. -1 times 3, 0 times 0. Okay. If I want this answer, bottom row on the left side, we have to use the bottom row and the left side. Careful. 3 times -3 is, we can jot little notes here. We have -9, and we're going to add to it what? -20. -29. Okay. So if we want the bottom row right-hand column, We have to use the bottom row, right-hand column. 3 times 3 and -4 times 0. So we get 9. Questions? When you get to college, if you're anything, anywhere part of a math major, you'll probably have to take a whole semester on matrices. We're just doing 1 day. Okay. Questions on multiplying them? Dividing is very involved, and we won't get into that. That takes a very, very long time to divide. I don't know if you do that. You may do it in college algebra. I'm not sure. I'm not sure. Questions on this, though? Okay, one last thing. This is a very quick and easy way to figure out if you can multiply 2 matrices together. So let's say we had these 2 matrices. They can be any numbers. That's why I put letters in there. So we have A, B, C, D, E, F. And we're going to multiply it by G, H, I, J, K, L, M, N. So just like we do rows times columns, that's the order that you say the size of a matrix. So how many rows and columns are on the first one? 3 rows and 2 columns, right? So this is a 3 by 2 matrix. This would be a, how many rows? 2 by 4. So these are the 2 sizes of these matrices. The first one's a 3 by 2. The second one's 2 by 4. If those 2 numbers match, you can multiply them. And the nice thing about writing down the size of these is those outside numbers tell you how big the matrix is going to be for your answer. So if we multiplied these, we would end up with a 3 by 4 3 rows and 4 columns for your answer. So you'll know what size you will end up with based on that. Any questions on matrices? Remember, if you're adding them, you just add the numbers in the same spot. Multiplying takes a little bit more time.